So this approach, this is sort of the general way to go through any of these kind of problems. Um, First, we're going to define the time equals zero instant, the time final instant, the zero position, and the positive direction. The time equals zero instant and the time final instant, those, there's only one way to answer those. There's the right way and the wrong way. There's two ways. The other ones, there's more flexibility. Those are somewhat arbitrary. Sometimes you can make the problem the math a little simpler by making certain choices, but these are the really key ones. So, and what do we use to base our decision of time equals zero and time final on? What does that depend on? It depends. Well, so basically, it always depends on where we have information already, and like what the instant is where we have information, and what's the instant where we're trying to calculate new stuff. Okay, so this question asks us, how high is the bridge? What we know about it is we know that it's dropped from rest. So we know a velocity at the instant that it's dropped. We know an amount of time that it takes to hit the water, which you could think of as a time final. And so we have information. We have information right at the instant it's released, and we have information right when it hits the water. Okay, or I guess we're trying to find. Well, yeah, we have information right when it's released. We have information when it's trying to hit when it hits the water, and we're trying to find more information about when it's released. How high was it when it's released? So that tells us that our time equals zero instant has to be the instant that the rock is released. And our time final has to be the instant that it hits the water. If you don't choose those two that way, you can't solve the problem. Okay, so now our choice for where the position is equal to zero. There are a couple of sensible choices for that. I think most people would say position equals zero on the surface of the water. That's what I would do. But you could also choose your position equals zero to be at the bridge, at the location where it's released. Let's choose position equals zero on the water. And then what about the positive direction? This is a free fall problem. So there's nothing mathematically wrong about choosing the direction of motion, but on free fall problems, I strongly recommend always choosing the positive direction to be up. And then your acceleration is always negative 9.81 meters per second squared. So let's choose the positive direction up. And based on these now, we're going to start listing out the variables that we know and the variables we're trying to find. Okay, so I'm just going to cycle through all the 6 possible variables, and we're going to put them in these columns when it makes sense. So do we know the initial position? Do we know the position of the rock when time is equal to zero? No, and actually that's what we're trying to find, right? If our zero position, if we're measuring from the water, we're trying to figure out how high the rock is at the instant it's released, right? So we're looking for P sub I. Do we know P final? Yep. P final is equal to zero. Do we know V initial? Do we know its velocity at the instant it's dropped? Yeah. Anytime something is dropped, Well, if it's dropped from a stationary thing like a bridge or a building, it has a velocity of 0. If it's dropped from a moving thing, it has the velocity of what it's dropped from. I'll give you that for your notes after we finish this problem. But initial velocity is 0. Do we know the final velocity? Nope, we don't. And remember, keep in mind, it's a common mistake to think that when something hits the water or hits the ground, at that instant the velocity is 0 because the water or the ground stops it. But we can't make that assumption. Okay, so we don't know anything about the final velocity. Do we know the acceleration? That's right. It's free fall. So, and the acceleration is down. So the acceleration is negative 9.81 meters per second squared. And do we know T final? 2.5, that's given. Okay, so there are 3 equations that we're looking at. The V final equals V initial plus ATF. The PF equals blah, blah, blah. And the 2A, let me write them down. Let me put them up here because we're going to keep using these. Okay, so V final is equal to V initial plus ATF. P final is equal to P initial plus VITF plus 1/2 ATF squared, and 2A times the quantity PF minus PI is equal to VF squared minus VI squared. Okay, so out of those 3 equations, are there any that have PI in them and every other variable in it is in the no column? Yeah, it looks like the second one will work. So PF is equal to PI plus VITF plus 1/2 ATF squared. So substitute in the values. 0 is equal to PI plus the initial velocity times 2.5. 0 times anything is 0. So, and then plus 1/2 times negative 9.81 meters per second squared times 2.5 seconds squared. And so you get 0 is equal to PI plus, to do this calculation, I'm going to write it out the same way I do unit conversion. So we have 1/2 times negative 9.81 meters over seconds times seconds times 2.5 seconds, and that's squared, so times another 2.5 seconds. You get all the seconds to cancel, and you end up with 0 is equal to PI minus 4.905. No. So 4.905 times 2.5 squared, and you get minus 30.66. And what are the units? Meters. And so P initial is equal to 30.66 meters. Do the units make sense? We're looking for a position. Yeah, so that's a good sign. Does the sign make sense? Yeah, we expect that initial position to be higher than the final position, and so this says that it's in the positive direction up from the water. So that's a good sign. So this is the height of the bridge. Any questions about that one? Okay, so one thing, this is the thing that I want you to remember about initial velocities whenever a problem says something is dropped. So notice. If a problem says that an object is dropped, then at the instant it's released, the object's velocity is the velocity of what it's dropped from. So for example, at the instant an object is dropped from a bridge or a building, unless it's a very bad building, you know, because you don't want buildings to have velocities. They teach you that in civil engineering classes. The velocity is equal to 0, okay? At the instant an object is dropped from a helicopter, the object has the same velocity as the helicopter. And, you know, that would be given in the problem. Okay, let's do another one. And again, I would recommend just go through the exact same set of steps that I went through there. That's my recommendation. I mean, if if you've done this kind of stuff before and you have a way that works for you, that's fine. Like, I won't take off points for doing it right. But for most of you, I think it would really help to follow these steps. Yep. Well, if it depends which way the helicopter is going. If the helicopter is going up, then when the ball's released, it's going to go up for a short time, slowing down the whole way, reach the highest point, and then start falling down. If the helicopter is going down, then it's going to start with a downward velocity, and then it'll speed up the whole way. Well, yes, I mean, it's still in free fall, so it's still going to accelerate at negative 9.81 meters per second squared. So you'd use that to figure it out. Okay, so say that a ball is thrown straight down from the top of a 10-meter wall. And it takes 0.7 seconds to hit the ground. How fast was the ball going when it's released? Okay, so first I want to make sure that you understand this this thing that I just said 1 second ago, this notice thing. So what's the difference between this problem and the problem that we just did with the bridge as far as the velocity at the instant it's released? Because, you know, I don't want you to get confused and say, like, the thing that you just said suggests that the velocity should be 0 when it's at the instant it's released. What's the difference? Yeah, that it's thrown. So if something says dropped, you know that its velocity at the instant it's released is the velocity of what it's dropped from. If it says thrown or launched or something, there's going to be some extra velocity one way or the other. Okay. Okay. Take a few minutes and see if you can work through this and talk to each other about it. I would recommend just going through those steps. I think it's a really good habit to get into.